Hello everyone, welcome back to my channel. Myself Sandesh Gowda, studying in Sri Venkateswara College of Engineering, Bangalore, Department of Information Science and Engineering. Uh, Let us take some topics in cryptography, that is encryption techniques. What is meant by cryptography? A cryptography is a method of storing and transmitting data in a particular form so that only those for whom it is intended can read and process it. So it's like, for example, encrypting means you are encrypting the data, like you are creating a Google password, right? So it will show dot dot dot. It will not be clear. It will not be visible to anyone. So like that only encryption and decryption is made. Uh, the types of cryptography is symmetric key cryptography, that is secret key cryptography, and the second one is asymmetric key cryptography, public key cryptography, and hash functions. Sub- Encryption techniques. In that substitution techniques, the two basic building blocks of encryption techniques are substitution techniques and transposition. So these are the two building blocks of encryption technique. That is substitution technique. A substitution technique is one in which the uh, letters of plain text are replaced by other letters or by numbers or by symbol. For example, uh, let us take 1, 2, and 3 as the numbers. So we are substituting the alphabet according to the what we have the sequence in the alphabet. Right? So 1 is A, so 2 is B, and 3 is C. See, like this, we are substituting the uh, alphabets to become a ciphertext. So ABC is a ciphertext now. So if the plain text is viewed as a sequence of bits, then substitution involves replacing plain text bit patterns with ciphertext bit patterns. So 1, 2, 3 is a plain text, means then ABC is a ciphertext. Next, in that substitution, next comes the Caesar cipher. The Caesar cipher involves replacing each letter of an alphabet with the letter standing three places further down the alphabet. In here, for example, A. A is a plain text, right? Now, we are considering A is a plain text, three places further down the alphabet. So, A, B, C. D. So, three place. So, B, C, D. This is the cipher text for A. So, D is the cipher text for A. The algorithm can be expressed as follows. For each plain text P, substitute the ciphertext letter C. C is equals to E of 3 comma P, that is P plus 3 mod 26. Why we are doing mod 26 means, so there are 26 alphabets, 26 English alphabet. So we are using mod 26. A shift may be of any amount, so that the general Caesar algorithm is, so here there need not to be only 3, it can be 2, 4, 6. However, the encryption coder will think, so he is giving the key value here k, so it may be 2, 3, or 5, anything. The general algorithm is C is equals to E k comma P is equals to P plus K mod 26. For example, meet me after the Tunga party. So meet. M E E T, meet. So for M, so M N O P. When we take K is equals to 3, then after M, 3 places further down the alphabet, right? N O P. This is the cipher text for the M. So they are given M. M is the cipher, P is the cipher text for the M. So like this, for entire sentence they have made the cipher text. For example, encryption for K is equals to 2, where key is equals to 2 K. So plain text is ABC. Then what will be the cipher text? A is the plain text. B C, right? So further 2 letters down. So A is the plain text. B C. This is the cipher text for the A. So as I have shown in the PPT, for A, C is the cipher text, for B, D is the cipher text, and for C, F is the cipher text. Next, monoalphabetic ciphers. Instead of shifting alphabets by fixed amount as a Caesar cipher, so in Caesar we are shifting the alphabets in a fixed way. So when K is 2, K is 3, we are shifting 3 alphabets or 2 alphabets, right? Here it's not like that, not like that. Caesar cipher. So any random permutation is assigned to the alphabet. This type of encryption called monoalphabetic substitution cipher. For example, A is replaced by Q, B is replaced by D, C is replaced by T, etc. Then it will be uh, comparatively stronger. So they cannot know what we have replaced, right? If we are using Caesar cipher, right, they can easily identify when K is equals to 2, what is the, if they see 3 to 4 lines of cipher text and plain text, they easily can understand what they have done here. So here in mono alphabet, it's not like that. We are replacing the alphabet by another alphabet. We are only replacing the, giving the reference alphabet for the plain text alphabet. So it will be stronger than the Caesar. Next, fair plus cheaper. It is in this technique multiple, that is 2-letter encryption at a time. This technique uses a 5 cross 5 matrix, which is also called key matrix. Any key can be used, but we use here, for example, we are using a key monarchy, right? So this is the 5 cross 5 matrix. What is the, here we have shaded right in gray color. This is the key alphabets. We have rules for the fair play conversion. Repeating plain text letters that are in the same pair are separated with the filler letter. Filler letter means it's a X. X comes the filler letter. It is the filler letter. Whenever if we are dividing name into 3 parts or 2 parts, right, then what will be the, if it comes only 2 letters at last, it should be 3, right? Then we need to add a filler letter, that is X, so that the balloon would be treated as a ba. Two plain text letters that falls in the same row of the matrix are each replaced by the letter to the right with the first element of the row circularly following the last. For example, AR. AR is the plain text. What is the cipher text for this? R, M, right? R and M. Next, two plain text letters that fall in the same column and each are each replaced by the letter beneath with the top element of the column circularly follows the last. For example, here you can see as M, U is the plain text, encrypted as CM, CM, MU is the plain text, encrypted as CM. We are next. Otherwise, each plain text letter in a pair is replaced by a letter that lies in its own row and the column occupied by the other plain text letter. Thus, HS, H, and S being replaced by B and P, and E and A becomes I and M. See here it is the H, and here it is S. So it has become BP. So we in column we are doing that column substitution, right? So in this is the ciphertext for H, and P is the ciphertext for S, and for E and A becomes I and M. See here we have E and we have A here. So for E it is the I, and for A it is M. Next, IL cipher, developed by an mathematician listener Hill in 1929. The encryption algorithm takes m successive plaintext letters and substitutes for them m ciphertext letters. The substitution is determined by the m linear equations, in which each character is assigned a numerical value. For example, a is equal to 0, b is equal to 1, up to the z is equal to 25. See, C1, C2, C3, these are the ciphertext, and K1, P1, K2, P2, K3, P3 mod 26. These are the key values and plain text. This mod is because we have 26 letters in English alphabet, so we are using mod 26. So this is the actual formula. C is equal to KP mod 26. Next, here we have, for example, where we have given ABC up to the Z, and they are given the values 0, 1, 2, 3, 4, 5, 6. So we have to encrypt the message plain text act. N is equal to 3. So we have to encrypt the plain text for the act, right? The key is GYBNQKURP, which can be written as the N cross N matrix with the help of above given table. So G is 6 and Y is 24 and B is 1. So we are writing like that only matrix. K is equals to, we are writing the what are the values they have given for the alphabet. So we are converting that into matrix, and with reference to above table, a message hacked is to be written as a vector. So hacked means A is 0 and C is 2 and T is 9. Here T is 19. So C is equals to PK mod 26. What is the P? 0 to 19. And what is the K? This matrix. This is the 3 cross 3 matrix. This is the K and mod 26. If you multiply this matrix, we get C is equals to 67, 200, 222 and 319 mod 26. To find mod 26, divided the number by 26, then the remainder will be the cipher text. So 67 mod 26 is 15, and 222 mod 26 is 14, and 319 mod 26 is 7. So cipher text will be 15 P, and 14 is O, and 7 is H. So this is the ciphertext for the message act. So for message act, this is the cipher text. So this is the end of the slide. So thank you. Have a nice day.